So you all are familiar with the data structure, and we have discussed linked list, which is a type of data structure. So let's have a quick review what we have discussed so far. If you remember, a data structure. Okay, one more student is here, Ms. Amal Shaheen, that's good. So data structure is a way to store and organize data inside computer system. And a linked list stores elements in a sequence of nodes. So we need a class to represent nodes. It's too low. Okay, let me check. Is it okay now? Not clear. Not clear? So you all are familiar with data structure? So data structure is a way to store and organize data inside computer system. And linked list is a type of data structure. We have discussed it. Let's have a quick review what we have seen so far. If you remember, a linked list stores elements in a sequence of nodes. And we need a class to represent nodes. So if we are talking about singly linked list, a node object stores an element and a reference to the next node. So in the previous face-to-face lecture, what we have done, we have created an inner class which was defined inside another class. And the methods of the outer class can access the public features of the inner class. You remember? We have created a class called node, which was an inner class, and that class was created inside linked list class. So the methods of outer class, that means linked list class, can access the public features of the inner class. And inside inner class node, we have declared two variables, public object data and public node next. Because the inner class is private, so it cannot be accessed anywhere other than the outer class. Now here you see a sample program. This sample program is a ListTester program which performs three main operations. Firstly, it will insert strings into a list, and then it will iterate through the list. That means it will keep on adding and removing elements, and finally it will print the list. Now see this program. Here you have two Java packages, linked list and list iterator. So these are imported. And then a class called ListTester. Now inside this ListTester class, you have main method. And then an instance variable is created, which is named as staff. Now, staff.addLast, and within braces you have Diana. So that means first data is Diana, and it will be added in the linked list. Now, next is staff.addLast Harry. Now, Diana will become first node and Harry will become second node. And Diana will point to Harry. Here we are working with linked list. And in linked list, one node holds only one data and next node holds second data, isn't it? So that's why if I want to add 4 different values, I'm using staff.addLast 4 different times, one for each node. Yes, because in a node, what we have an element which is stored and a reference to the next node. So if I want to add 4 different data items, 4 different objects, I have to create 4 different nodes because one node can hold only one data. Is it okay? Now next is staff.addLast Romeo and staff.addLast Tom. Now here we have a list iterator and it will indicate the position where initially the pointer is. Now if you see list iterator string iterator is equals to staff.list iterator. Now you have inserted 4 different values inside your linked list. So initially the pointer is at this position because it will point to first node. Yes, before first, because it will point to first node. Okay. Now when you will use iterator.next, what will happen? The position of iterator will change and now it will point to second object. So it will be before second object. Yes. Before first, no, not before first, before second and after first. Yeah? Yes. It will be before second and after first. Now next is iterator.next. So again the position of iterator will change. Now it will point to the third object. So before third, yes, and after second. Now what we are doing, we are adding other elements. We are adding some other elements. So here we have iterator.add Juliet. So earlier what we were having just 4 objects, 4 data values, Diana, Harry, Romeo and Tom. Now what we are doing, we are adding some more elements. So Juliet and Nina. So since iterator position is here after Harry. So when you will add something, it will be added after Harry. So Juliet will be added over here after Harry and the position of iterator will change. It will move one position towards right. Now next is iterator.add Nina. So iterator position is between Juliet and Romeo. So when you will add Nina, it will be added between Juliet and Romeo. Yes, and position will be after Nina. And then you have iterator.next. So again, the iterator position will move towards right. So it will be between Romeo and Tom. here. Is it clear? Yes, Miss Munera, you were typing something. It's okay, it's clear. Okay, that's good. What about Miss Amal? Okay. Now when you want to remove any element, you will use remove function. So iterator.remove. Now can you tell me which element will be removed when you will use iterator.remove function? That before a position, fifth one. Okay, can you give me the reason for your answer? Because the pointer is after the 4 and before 5, which refers to the position is moved, not element. See, always that element will be removed which is last traversed, which is last referenced. So here the pointer is between R and T, means Romeo and Tom. So which one is the last visited node? Yes, R. So it will delete the last traversed element. That means R. Okay. Okay, repeat. Now, Ms. Amal, can you tell me what is the current position of iterator? Where the iterator is? The current position. You don't know. Okay. See this one. You have Diana. Okay. Then you have Harry, Juliet. Okay. And then Nina, Romeo, and Tom. So the current iterator position is between Romeo and Tom. So which one is the last visited node? Which one is the last visited node? R. Yes. So when you will use iterator.remove, it will delete the last traversed element. So R will be deleted. R means Romeo. Here we have used short forms. The complete Romeo, that is an object, that is the data that is being stored inside node. So Romeo is deleted. Now next is, yes, Miss Munera, I think you are in the second line, not this. Second line? dhjn. Yes. So once, see here, iterator.next. Here the position of iterator is between R and T. Now when you will use iterator.remove method, what will happen? The last traverse node, that is R, is deleted and you get D, H, J, N and T. Yes. So this is the result when this function is executed, iterator.remove. And earlier it was D, H, J, N, R and T. No. See, iterator.remove method is called only once. Only once. Now if you will call iterator.remove method twice, again if you will use iterator.remove, then what will happen? Then in that case n will be removed because last visited node is n. This method is called only once. Okay? So the last visited node is R and it will be deleted. Now second time if you will use iterator.remove, then in that case n will be removed. And so on. Now next is for string name staff. Staff is this one. This is the instance variable that you have created, staff. Now system.out.print name plus. And after that system.out.println and system.out.println expected Diana, Harry, Juliet, Nina, Tom. Now can you please tell me what will be the output of this program when you will execute this? When you will execute this, what will be the output? Only expected Diana, Harry. Yes, this will be printed. Okay, this will be printed. It's clear because you have system.out.println expected. This will be printed, no problem. But what about this? What about this? Before this, what output will you get? They will print all the name, each one in separate line. Okay, so can you tell me the output, please? Use your chat box and type the complete output that you expect will be printed when you execute this program. Okay, Diana, Harry, Tom, then Diana, Harry, Tom. That means this one. And what about Juliet and Nina? It will not be printed. Diana, Harry, Juliet, Nina, Tom. Okay, let's see the output. Here you have system.out.print and then name plus. So what's the first name? What's the first name? The first name is Diana. So firstly, Diana will be printed. Okay. And then Harry, Juliet, Nina, and Tom. These are printed. And after that, this statement is printed. Expected Diana, Harry, Juliet, Nina, and Tom. Now let's see the output. This is the output. If you have any question, you may ask. Yes, you have println, but when you will execute it, the output will be, this is just to confuse you. The output will be in same line, not in different line. Println means print from new line. Yes, print from new line. But in this case, okay, we have name plus and then space. So name is printed and then there will be a space and then new output. Again space Juliet. Again space Nina. Again space Tom. And then from new line, this statement is printed. So far we have discussed about linked list, how to implement linked list, how to create a node class, and we also know that linked list class holds a reference first to the first node. And if first is equals to null, then it means that the list is completely empty. There is nothing inside that list. And we have also seen that it is very easy to add elements, to remove elements from a linked list. What you need to do is just change the pointer. Just change the pointer. So if the pointer is changed, okay, if you want to add a new node inside two different nodes, then you change the pointer reference of first node and the pointer reference of the new node that you have created. In that sense, you can add a new node. And if you want to remove any existing element, just change the pointer position. So you can link first node with third node. In that sense, the second node will be deleted. Now in next face-to-face lecture, we will discuss about other data structures which are known as stacks, heaps, trees, maps. So we will discuss them one by one in our next face-to-face lecture. And if you have any problems so far, you may ask. Okay, thank you all of you for coming. See you in next face-to-face lecture. Till then, take care. Assalamu alaikum.